All right, good morning, everyone. Today is February 10th, 2025. Nice and sunny Monday morning, all right, 11 a.m. Cool. All right, so today we are going to start a new chapter that, okay, it's supposed to be fading in. I had some really cool effects, and I keep pressing. Oh, there we go. All right. We're going to start the telephony part of the unit of our class, telephony unit. So over the next this week and next week, we will cover the telephony part. Today we're going to get some basics on how basically telephony works. All right. We'll talk about what USOC is, we'll talk about what POTS is, and maybe in this lesson, I will introduce you to the concept of the 24-pair color code. However, sometimes it stretches on to the next class, but we have the whole week to do this here, all right? Okay. Now, this is quite obvious, but some people deserve certain recognition on certain level, and here's my tribute to that wonderful person. He invented the I'm pretty sure most of us know who I'm talking about. So let's just go through the motions here. He invented the telephone. So there you go. When he was 29. So excuse me, about your age, guys and gals, all right? Excuse me. His first words spoken on the telephone were, Watson, come here, I want to see you. And it was March 10th in 1876. Wonderful year, I suppose. He refused, he refused to keep a telephone in his office because, in his view, a telephone was a distraction. So in 1876, there already was a wonderful invention that was already viewed as a problem by the person who invented that. So that's that's a little bit of a funny story, because look what's happening now. Just go outside at any day of the week, any time of day, and you're going to see people crossing the street glued to their phone. There are many ways to die, I guess, and this is one of them. All right. So what inspired him to invent this contraption, as they called it? His mother, Eliza, was hard of hearing. Speech pathology was of his interest since the early years of his life, because he was basically exposed to that kind of a problem, and he wanted to help his mom. More info if you want. You can click on that when you download this. But this is just one of the nice links. I don't even need to give you a link, because if you just punch Alexander Graham Bell in YouTube or Google, this thing is going to light up for you. And here is the person. All right, I've seen some animated story, which was actually pretty well done. When I find it, I'll give you a link to that. It's going to give you some more view on that. In my opinion, a wonderful person who did more than just a phone. Right. All right. So the first telephone looked like this. You can pretty much, if you have seen some of the old black and white movies, that you can see people talking on the phone. This would be the phone they would be talking to. Here's the mouthpiece, and here's the earpiece. So you would take this earpiece off the cradle, and here would be a switch that would make a light up at the switchboard. And the person who would be sitting at the switchboard would see the light and would patch with the 1/4-inch cable into that nest that that the light indicates. And the person on this side, they would not hear the dial tone, because the dial tone was not originally part of the telephone system. It was just later when automation kicked in. But they would hear the good old famous number please, number please. You know, that's what, you know, that's what people would hear. Okay, here is the receiver piece. Here's the mouthpiece. And here is something that was called the Centennial transmitter. Pretty simple in our standards right now, because things are quite obvious to us right now, but they were not obvious at that time. But that was using the electromagnetic concept, or the magnetism or electromagnetism, that made the whole thing work, the whole thing possible. Now here, I'm trying to find the name of that actor, and if anybody has any research abilities or whatnot, if you could find out, I would be greatly appreciative. Here's an actor portraying Alexander Graham Bell in 1926 silent film. Shows Bell's first telephone transmitter microphone invented in 1876, and the first displayed at the Centennial Exposition in Philadelphia. Now, just to kind of give you the idea of how big of a deal that was, over the centuries, we humans tried to do better. We were always not satisfied with where we are, and you know, that's a curse and a blessing, because if you constantly unsatisfied, it would make you a miserable person. However, if you're constantly not satisfied in the right way, then progress begins. Okay, so I'm pretty sure at some point we were sitting in the trees and scratching behind our ears and wondering what to do next. However, somebody was not satisfied with that. They came down on the touched the ground, and that's my really distorted legend. My version of that. We came off the trees and we started progress. Fire, somebody knew how to do fire, right? And then fast forward, and we always strive to communicate better, right? Over distance. Because when we were talking, first the communications were troublesome, because there was no language. There'll be just some kind of recognizable sounds that if somebody is happy or somebody is sad or somebody is angry. All right. Then the verbal communication began, but that was not enough, because we needed to communicate over distance. So shouting began, but when the voice couldn't carry, we were doing all kinds of things. Like, for example, in our native culture here in Canada, we have the wonderful tradition by the native communities, and doing the smoke signals. That was a form of communication over a distance. In Africa, some years ago, there would be things that were called the tum-tums, and there would be those drums that would carry low frequency over a distance, and certain drum beating would mean some sort of message, right? Later on, pigeons were used a lot, because homing pigeons always come home. The only thing is that if you run out of pigeons that you grab from the coop, then you are done with the communicating over distance, right? You have to mount the horse, or send somebody with a message. Then fast forward, and we would just do hand signals over the ships, over distance, light, Morse code. And then the telegraph began. All right, the Telegraph Road. If you want to listen to the extremely, extremely wonderful piece by Dire Straits, was the Telegraph Road. it basically picturizes what I'm saying right now, but in a much nicer way. All right. Now, how big of a deal was it to communicate over distance? Well, we couldn't before, and it was hard to do. And all of a sudden, there's a breakthrough. Kaboom! All right. You can communicate with voice before you have to write a letter and wait maybe a week or two before some stagecoach comes and carries that to another town or city or a country. But there would be weeks and sometimes months before somebody would even get the message and then reply that. Well, things were not happening instantly as they do now. We take things for granted, however, at some point they were not. So how big of a deal was it? Well, look, here is a movie that was made, and it was, I suppose, sensational movie at that time. And the movie was made about using a telephone. So it was a huge deal. Right? And funny enough, it was a silent film about using telephone, all right? So it was a big deal. We do takes for granted. Now, how big of a deal was that? Look how cool this guy looks and how cool this guy feels, because he has something on his desk that he can communicate with other people instantly, all right? Now, that would probably cost a lot of money then, and only the elites were able to use that. Now, there were demonstrations on how to use the phone. People would dress up in suits and ties, and they would just go and see the demonstration on, yes, I can speak to someone 5 kilometers away or a kilometer away, and we could communicate. Now, how was it that the CO, and here is the first acronym that I'm introducing you to, all right? CO stands for Central Office. Well, here's the small town, probably switchboard. I'm not sure how many circuits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20, 30, 40, about 80 points here. I'm not exactly sure how this thing worked, but small town, 80 people, well, would have phones. In the early days, what does she have? She does have a set of headphones, so she could hear the person that she would patch. Here is the quarter-inch plugs, quarter-inch plugs that were used into quarter-inch jacks, because the diameter of that is quarter-inch. If anybody plays a guitar or in the pro audio business, those jacks are still being used in audio industry. And that thing here, hanging on her chest by the lanyard here, that's actually a microphone. Technology was not as forward as it is now. However, I'm pretty sure in 200 years from now, some things that we consider high tech would be considered maybe obsolete or sentimental, at least, at the most. Right? Sorry. So that was the central office. So that's why the lines, a regular telephone line, POTS telephone line, here's another acronym I'm introducing you to. POTS stands for plain old telephone service. So a regular POTS line, which consists of one pair. So in communications, we talk about pairs, because one pair is one communication link or one communication hardwired connection. Now, that one communication hardwired connection could have more than one link, consider something that's called multiplexing. But as far as hardwired things go, before one conversation, one telephone conversation would mean one telephone line. Before even the concept of the pairs was introduced, because now we have something that is called a loop start type of a connection. A loop is there's a pair dedicated for one hardwire connection, a pair of wires. Before, a line would be dedicated, one line, not a pair, one conductor. And the return path or the ground reference was provided by the ground itself, the earth. Right? So there would be telegraph lines, for example, each line as one channel, and on the hydro utility poles, usually stretched along the railroad tracks because the pathway was already established between towns, and the ground reference was provided by the ground. Later on, to improve things, the ground idea was skipped and another wire was introduced because the quality of the signal was greatly improved. If instead of using a ground as a ground reference, you could use another wire as a ground reference or return path of the signal, have a closed loop. So sometimes when you have the programming of the telephone lines, when you program a phone system, in the part of the line programming, which would be telephone lines programming, you will have to choose something that's called either a ground start or loop start. Now, ground start is never used anymore because nobody uses ground as a ground reference anymore. So I have no idea why that option is still there. It beats me forever, but who cares? We know that in order for the line to work properly, the type of line that the phone system or the phone box recognizes, it has to be chosen as a loop start. How to start or initiate the phone call. Loop is basically a pair of wires. One as a hot wire, the other one is a return path, and those we call tip and ring because those jacks would have a tip right here and they would have a ring around it. So one wire would be connected to the ring of the jack and the other one wire will be connected to the tip of the jack. So each telephone line doesn't have, well, it does, but we don't call it as positive and negative. We don't call it as plus minus. We call them tip and ring because of that old times that things were initiated in this old central office patch panel switchboards. All right. Now there we go. Now in bigger cities, as things expanded, and they did expand rapidly, there was a whole working culture of the central office switch panels, and it was quite sophisticated for that time. Actually, it would be quite sophisticated to make to wire something up like this. It would not be a small project. So there would be a whole working culture. Look, this would be, I'm not sure what city it was, probably somewhere in the States. Could be New York, could be Chicago, could be, well, this looks like some sort of international switchboard because over here there would be wires that were have access to London, England, it would be Paris, and something else I can't even see here, but that looks like an international switchboard. Well, later on, if you fast forward, that's what the CO or central office looks like today. There's no humans, everything happens automatically. It's all digital technology right now. Before digital technology kicked in, there will be some analog circuits, but we're going to skip that because this is not a history lesson, all right? But I'm just giving you enough information so you can connotate the terminology, where it begins, where it originates, and why we call things as we do. So CO line is a telephone line. Sometimes those telephone lines would be called SL, as for single line. CO line, SL, or SL line would be single line. So that would be a telephone, or POTS line, plain or telephone service line. So let's take care of that tech stuff. How was it? There was a telegraph. Now, telegraphy that was patented in March 7th, 1876. And this would be how telegraph was wired. Now look, the original, see, here's the ground connection here. We're going here. There you go. Here would be a line, and this could be from one town to another. Right? And this only one line would service one channel. And the other part of this receiver, for example, or transmitter in this case, oh no, this would be a receiver because it would put that in your ear and he would speak to this here, right? But it would work both ways. The other part was connected just to the ground, to the earth. Right? The other part also to the earth. Now, by the laws of physics, Faraday's law, if you introduce a changing magnetic field to a wire, then during that change, electricity is going to flow. Electric current is going to be induced into that wire. Well, we could have a magnet here, magnet core, surrounded by a wrapped around coil, and one would be inserted into the other in a way that they don't touch. If you started talking to this speaker or this microphone or the membrane, it would make the membrane vibrate, and it would vibrate with the frequency of your voice or with the shape of the waveform of your voice. It would create electricity. So this would be a transducer, would convert the energy, one form of energy to another, mechanical air vibrations, longitudinal waves, into the electric signals. Then the electric signals, the waveform would be introduced into this coil right here, and it would make physically the magnetic core vibrate and move the membrane, so you could put your ear to it and you could hear that. And of course, in order to boost the, and I'm going to invent the word, the powerfulness of this whole thing, a battery was introduced, a DC battery. Well, that's why here's another term as far as terminology goes. When you're diagnosing telephone line, right now you're looking for two things. You're looking for dial tone, and also you're looking to see if the battery is present. It's a terminology. Is the battery present? That means there's a voltage between those two conductors of one line. And that originates from here. Now, notice one thing. Because if I could bring up my board here, figure out what was wrong last time. DC battery. Here is the longer prong or line of the battery symbol. Here's the shorter Here's a DC battery. Here's a symbol of a DC battery. So the longer one is the positive side of the battery and the shorter one is the negative side of the battery. And if this is 1.5 volts, we are going to have 1.5 volts across these two terminals. And if we keep stacking them here and so on, so here's 1.5, 1.5, and another 1.5. So here's 3, 4.5. We would have 4.5 volts. Of course, if we reverse that graphically, we could have minus here and positive here. Now, we could connect that because battery is just a free-floating device. If we connect the positive side of the battery to the ground, then the positive side of the battery is going to be at the same potential as the ground, right? All right. So at this point, we would have minus 1.5 volts, right? Or whatever the voltage of the battery is set to be. Keep that very important concept in mind right now. It is a very important concept with what we're doing here. Because look how this battery is wired. This here, whatever the battery is, this is just a symbol of many battery cells. And right now the voltage in the telephone line is 48 volts DC, but it's negative 48 volts DC here. Because the positive side of the battery is connected to ground. And right now, we don't have the ground connection, we just have a line that goes from here to here. So we have a pair. And at some point, that thing could be grounded. So the positive side of the battery, of the DC power supply, is sitting at the ground level. And the other part of the battery is negative, is even more negative than ground. The reason for that was that originally things were reversed. The line would be positive and the ground would be negative. But since we had the copper lines stretched from one pole to another and so on, somehow it made that copper corrode. Those copper lines corrode. Reversing the polarity like this, that this positive side of the battery was on the even grounds with the ground, and those lines here would be idling at the negative 48 volts DC. It would solve, for some reason, it would solve the corrosion problem. Okay, so that's why the tip and the ring are the polarity as they are, and we're going to analyze that in detail. So this is a picture. It was a pretty, I would say, pretty good job as a telegraph operator, because with the telegraph you would introduce short spikes, and those would send spikes into the electromagnet on the other side. So I know I said about this membrane vibrating and the other one vibrating according to, just to mimic the first one. That was later. originally it was just a telegraph, so you would just go and notice that something has happened, and you would then something like a Morse code was developed, and that's how things were being used. Now, the Morse code was used for a long time. Morse code is not an official ways of communications anymore. I think the last official communication with the Morse code was sent, and don't quote me on that, it was something around early 90s, like 90, somewhere between 91 and 93. I think it was 1993 that the last official communication with Morse code was transmitted, and that was it, because the new technology, more advanced technology is being used, so the Morse code is not needed anymore, even for the distress famous SOS sent by the ships. So that is not even official now. Now, is Morse code still being used? Yes, it's being used by so-called radio enthusiasts, so amateur radio enthusiasts. And in order to be able to transmit, you still have to have a legal license to do that. You need to have some sort of information, some knowledge, so you don't cause havoc in the electromagnetic waves spectrum. Yes, but so it's used, but not on a commercial, not official basis by the radio enthusiasts. Yes, it's being used. This would be the telegraph lines that would be stretched later on. They were being used for telephone communications, and usually they would be stretched along roads or more likely railroads, because it will, of course, it will be established path between one town and the other. Okay. And if you want to get sentimental, I have a song for you that you can click on, and one evening with a good cup of coffee, you could just get sentimental and listen to the Telegraph Road song by the Dire Straits. That's if you want to get that kind of in the mood. All right, you could still see some of the abandoned telegraph lines or telephone lines along the railroads. Just drive out of the city a little bit, see where the railroad is. You are going to see some abandoned, ripped apart, old telephone or telegraph lines that they go back long way, and at some point there will be a lot of busy traffic on this thing. Not anymore. They're just silent witnesses to what was happening long ago. Right? Now, here's the idea of a tip and ring. Here is a 1/4-inch jack. Now, tip, ring, and sleeve. So you have 3 connections here, and sometimes you just have tip and ring. So these two are joined together, like it's just one piece. Tip is always more positive with the rest of them, right? Ring and sleeve. TRS, foam plug, still being used in audio industry. A typical guitar cable plug. Right. Now, you see, tip is positive, ring is the negative, and sleeve is the ground reference. That's if you want to send something that's called a balanced signal. We'll talk about that. Now, you see here, we'll talk about the ground level. How is the tip and ring being solved? Now, tip is more positive than the ring. However, tip is equal to the ground. See here, tip. Here's the tip, and it's equal with the ground level. And here is the ring, which is more negative than the tip. It's connected to the minus 48 volts. And this is the red and green tip and ring, or green and red tip and ring, of the POTS, plain old telephone system or telephone service wiring. And originally you do have the green and red color jacket of the conductors. Green is tip, red is ring. Easy to remember because ring and red both start with R. Okay? And just remember, the tip is always more hot, more positive than the ring. And this, you just have to look at this thing a few times and long enough just to absorb that sort of idea. And as I said, the only reason why the polarity is as it is, it's because those telegraph lines or telephone lines will be corroding. So that was quickly solved by changing the polarity. USOC stands for Universal Service Ordering Code. And it has to do with the wiring of the telephone jack. The telephone jack, RJ, stands for registered jack. Why is it called registered jack? Well, the reasoning behind that is that when in the early years of telephone existing, different sub companies, because AT&T was the probably the company that would have monopole on things in the States. But they would hire different companies to do the connections, or different individuals, and sometimes on an individual basis they would invent their own way of connecting things, because things were not very complicated. Things had to be done, and things were done. So small companies, individuals would develop their own improvised way to make it work. But when things got way more popular, some kind of a systematic ways of things had to be established, because then it would be a big mess. If it was just one here and one there, no problem. But if you're talking about the whole city of Chicago needs to have a lot of phones, then some standardization had to happen. So USOC was developed, Universal Service Ordering Code, and this has to do with the way the jack looks like. Registered jack, officially registered jack. So there will be companies who will produce those jacks, and there will be companies who will be buying those jacks, and there will be companies who will be installing, but everybody does the same things the same way. So that's called RJ. Now 11 is just a cataloging number. Could be a jack RJ11, RJ12, RJ45. You pretty much heard that term. RJ45 is the computer Ethernet type of a jack. Okay. USOC wiring configuration. That was the original. See, red and green. Tip is more positive, but it is connected with ground, and it's easy to remember because it's green. Grass is green, ground is green, ground is green jacketing. But it is more positive than the ring, but it is connected to the ground. So the ring is more negative than the ground. So here is line 1, tip and ring, tip 1 and ring 1. Now, how does that translate into the jack? If you follow those lines, you're going to find that those are going to the very middle of the jack. So here is pair 1, the middle prongs. Now, when we go with the USOC configuration, we just go outwards. Here's pair 1. All right. Here is pair 1. We go outwards. Here is pair 2. See, blue, orange. Here. Now we keep going outwards. Here's pair 3. That's the USOC configuration. When we wire data, we wire a little bit different. And remember I showed you how to do the dance. Blue, orange, green, brown, right? Blue, orange, green, and brown. That was the dance that I did. Now, how does that translate into the original wiring with the red and green, or green and red? Look, here would be tip and ring, and there would be a tip and ring, and then ring and tip outwards. They would be all the same, kind of on the same side. They just go outwards, and the first pair would be green and red, and usually each jack would contain one telephone line, and it would be wired to the middle two prongs, and it would originally be green and red. Now, it is very hard to get those old type of wires right now. And why would you want to if you have something better and, well, I would say equally inexpensive? The price is quite civilized right now. You would have the Ethernet cable that can, yes, it can be used to transfer telephone signals, because telephone signals do not have as much expectations as far as the specs, as far as the bandwidth and other specifications that the data has. So data has way more, is way more sophisticated cable, but that way more sophisticated cable can carry, yes, it can carry the less sophisticated signal as it is phone signal. So we can, and we do use data wires to convey telephone lines. So if you remember well, we already did some stuff in the lab connecting jacks and plugs. So remember, you have the first four pairs: blue, orange, green, brown. And if you want to complete the five, would be slate, which is not included here. But if you would connect telephone line through a Ethernet cable, Cat5e or Cat6, you would just choose one of the pairs. And since here's pair 1 is blue pair, and the pair 1 is red and green, then this is how things translate. Then it would be black and yellow, and there would be white and blue. And this is how, but usually one pair conveys one telephone line. Now, there's other ways of connecting phone lines, because this data cable, blue, orange, green, and brown that is not here, is capable of carrying 4 telephone lines because it has 4 pairs. We will address that later on how to wire things, and we're going to have a lab so you retain that knowledge. Typical, see, here's the RJ14. 14 is just a cataloging number of what this is. Right. Surface mount telephone jack. You mount that on the surface, on the wall, along the baseboard, and whatnot. And look, this one here is capable of carrying 2 lines. Line 1 would be red and green, and line 2 would be black and yellow, but usually, by far, one telephone jack would be installed to carry 1 telephone line, so you would just connect the green and red, or red and green. That would go to the 2 middle prongs of the jack here. Here's another visual of how to use the tip and ring, how to designate the tips and rings of the, well, Ethernet cable. See here, pair 1, the green goes to the stripe, and the red goes to the solid. Then the black goes to the stripe, yellow goes to the solid, and so on. And if you want to convey that, just extend that cable with this cable, then you would just not use the brown pair, because this here we have only 3 pairs, and sometimes we only have 2 pairs. Okay. Demarcation point. This is how things are getting applied. All right. I'm going to stop on this slide, but I'm going to explain what it is, because we're hitting that 10:2 mark. Okay. As far as timing wise for the class. So here is the demarcation point. What's a demarcation point? Demarcation point is basically a point of entrance. So it would be the point of entrance of the wiring to the building. Okay. Now, how is this little device wired? Here is a ground slag or ground connection. It is connected straight to the ground. Now look, this here demarcation point, the way it is wired up right now, is capable of 2 lines. It can have 2 more here, and it can have 2 more here. So the capacity of that, at the most, of this enclosure is to carry 6 lines. But the way it is wired right now, it is wired for the possibility of carrying 2 lines into the building. So here is a tip, and here is ring. See, here's the green wire, and here's the red wire. Now, internally, they are connected into these 2 terminals here. Actually, into this jack right here. And here's the RJ11 telephone jack. You can unplug that. If you plug it in, you would connect these 2 terminals as tip and ring into the wiring that you could connect into these screw terminals, and the wire can be extended into the house. So there'll be 1 line. Another line, here is the tip, green, and here's a red ring, more positive, but at the ground level, less positive than the tip. And it is wired into this jack, and that by this wire here is connected into these 2 terminals. Wire goes into the house. Another pair you can connect into another line into the house, and you can connect that, and you can disconnect that, and connect that if you want. Right? Now, this is also this demarcation point also has something called lightning protection. This here is normally acting as an insulator. This green mass here looks like a plastic, plastic form here. However, its ability to, or its resistance is not as, well, it is controlled resistance. Because when the lightning hits, if there is enough potential, if a lightning hits of an electric storm, and if any of those points are going to have those thousands of volts, then for the thousands of volts that the lightning has, this will be able to conduct, and it's going to take all that energy into the ground. All right, so that's why here is the lightning protection. And this typically would be sitting on either outside of the house or somewhere in the basement, where the electrical connection would be, electrical room, whatnot, and communications room, and that would serve as a demarcation point. All right, we're going to stop here today, and we're going to continue in person next time we see each other, whenever that is. And that's it for today. And I just want to wish you a wonderful week, and see you when I see you. Thank you.